Hi, I am T. Kavitha, Department Assistant Professor, Department of Mathematics. Today we are going to see the topic of limit of a function. Limits in maths are defined as the values that a function approaches the output for the given input values. Limits play a vital role in calculus and mathematical analysis and are used to define integrals, derivatives and continuities. It is used in the analysis process and it always concerns the behavior of the function at a particular point. The limit of a sequence is further generalized in the concept of the limit of a topological net and related to the limit and direct limit in the theory category. Generally, the integrals are classified into two types, namely definite and indefinite integrals. For definite integrals, the upper limit and lower limits are defined properly, whereas indefinite integrals are expressed without limits and it will have an arbitrary constant while integrating the function. Let us discuss the definition and representation of limits of the function with properties and examples in detail. Introduction to limits. Suppose we have a function f of x, the value a function attains as the variable x approaches a particular value such a that is x tends to a is called its limits. Here a is some pre-assigned value. It is denoted as limit x tends to a f of x is equal to 1. The expected value of the function shown by the points to the left of a point a is the left hand limit of the function at that point. It is denoted as limit x tends to a minus f of x. The points to the right point of a, which shows the value of the functions, is the right hand limit of the function at the point. It is denoted as limit x tends to a plus f of x. This is the diagram for this left hand limit and right hand limit. X tends to a minus f of x and x tends to x plus a plus f of x. And next we go on to the definition of limit. Let f of x be a function defined on an interval that contains x is equal to a except possible at x is equal to a. Then we say that limit f of x tends to a is equal to L. If for every number epsilon greater than 0, there is some number delta greater than 0 such that modulus of f of x minus L less than epsilon whenever 0 less than modulus of z minus a less than delta. This is the properties of limits. The following of the list of properties of limits. We assume that limit x tends to a f of x and limit x tends to a g of x exist and c is a constant. There is a two functions exist, then limit x tends to a c into f of x is equal to the constant c, we take it outside, c is equal to limit x tends to a f of x. You can factor a constant, that is a multiplicative out of limit. The second one, the sum of the two functions, limit x tends to a f of x plus r minus g of x, that is equal to limit f of x tends to a plus r minus limit x tends to a g of x. To consider the limit of a sum of difference, select the limits individually and put them back with the corresponding sign. This fact works regardless of number of functions we separated by plus or minus. Third one, product rule. Limit x tends to a f of x gx into f of x into g of x, then it is equal to limit x tends to a f of x into limit x tends to a g of x. Consider the limits of products similar to the limits of sums or differences. Just select the limit of the pieces and put back, and this is not the limit to only two functions. Fourth one, limit x tends to a f of x by g of x, that is the division rule. It is equal to limit x tends to a f of x divided by limit x tends to a g of x, provided limit x tends to a g of x that's not equal to 0. The next one, example for limit. To compute limit x tends to minus 4, the function is 5x square plus 8x minus 3. We use the property 2 to divide the limit into three separate limits. Then use properly to bring the constant out of the first two. This gives limit x tends to minus 4, 5x square plus 8x minus 3. We separate these, then we get limit x tends to minus 4, 5x square plus limit x tends to minus 4, 8x minus limit 3, x tends to minus 4. We substitute the value of x is minus 4, then we get 5 into minus 4 whole square plus 8 into minus 4 minus 3. Minus 4 square is equal to 16, 16 into 5 is 80, 8 into minus 4 minus 32, and minus 3 we got 45. The second example is to compute limit x tends to 6, x minus 3 into x minus 2 divided by x minus 4. Here we use multiplicative and division, two rules also. Therefore, we separate the limits. Limit z turns to 6 is x minus 3 and limit z turns to 6 z minus 2 divided by limit z turns to 6 z minus 4. We substitute the z value as 6, then we get 6 minus 3, 6 minus 2, 6 minus 4, 3 into 4 by 2, that is equal to x. The last problem is compute limit x turns to 3, x square minus 3 divided by x minus 3. Here we substitute x is equal to 3 in the step, we get 0 by 0 form. Therefore, the limit does not x. Therefore, you use property of squares. We separate the formula, factorize the x square minus 9. Then we get x minus 3 into x plus 3. Now, the x plus 3 term is cancelled. We get limit x tends to 3, x plus 3. Then we substitute the value of x as 3. We get 6. Thank you.